Hi everyone, in this video here we are going to make use of GeoGebra to visualize how trapezoidal rules is used to approximate the value of a definite integral. Where in this case here, we need to relate with the area under a curve, where we treat the definite integral that we're going to find out, that we're going to evaluate, that we're going to approximate, corresponding to an area under a curve. And this area here, we're going to approximate using trapezium, the area of a trapezium. So let's say we make use of these examples here. As you can see from the diagram, a curve labeled as y equals to fx. We would like to find out what is the approximate value when the time we integrate these functions from a to b, which is corresponding to finding the area under the curve from a to b, as shown in this diagram here, highlighted in blue. And in here I label it as the actual area under the curve. And what happens in trapezoidal rules too is that we make use of this red dotted borderline, the x-axis, to form a trapezium in the way that we connect this point here with this point here with a straight line, and therefore form a trapezium, and the corresponding area in pink here is referred to the area of the trapezium. From the diagram you can see that the trapezium area and also the actual area from the integrations, they doesn't cover the same area. There happens to have difference there. So how can we happen to make use of this trapezium here to estimate the actual value of the definite integral? So go on. Of course, by using only one trapezium, it is not good enough to do approximation of an actual value of the area under the curve, which is correspond to the definite integral. But if let's say we able to make the area under the curve here into more and more smaller strip of trapezium, by right at some point you happen to find out that the value should be close enough with the actual area. And now next, before we refer to the actual value, let us try to see in diagram wise what happens when the time I happen to insert more strip of trapezium. In here now I only have one strip of trapezium. As you can see that they are not really equivalent to each other for the area. What if now I insert in two strips? And then followed by 3 strips, 4 strips, and by right in our syllabus here, our iteration, our calculation, it will limit to 4 strips just for our syllabus calculation. But in the actual fact is that you can insert more and more strips. As you can see, when the time I insert until 4 strips here, you should see that the 4 trapeziums happens to be almost have the same regions as the area under curve. And what if I insert more strips? Let's say 5 strips, 6 strips, follow, let's say 10 strips, 30 strips. You can see that almost it happens that the trapezium area merge with the actual region. This is the idea what is going on in trapezoidal rules, where we try to using many strips of trapeziums to approximate the area of the regions under the curve, which happen to correspond to the definite integral that we want to calculate. Then the next thing I would like to go on for discussion is that we refer to the error. The error may occur when the time we make use of trapezoidal rules to estimate the definite integral compared with the actual value. So let's see. Based on these diagrams here, and from the software, we happen to find out that the actual area under the curve it happens to be having the integral value of 17.08 when the time I round off to 2 decimal places for these regions here. And with the time I apply trapezoidal rules, let's say now back to one strip, what will happens to be the area of this trapezium? I find out that the area will happens to be 18.905 when the time it comes to 3 decimal places. Then what is the error for these approximations here, which is happens that I takes the difference between the actual and also the sum of the trapezium's area, and therefore if it happens to give me the answer in this case here 1.825. So we can see the error is quite large here when the time we use one strip. Then what if I happen to go on with 2 strips? You happen to see now the error is getting smaller, where the sum of the trapezoidal rules, the sum from the trapezoidal rules is the sum of the trapezium's area is happens to be quite close to the actual integral value. What if now I go on with 3 strips? The error getting smaller. 4 strips, even smaller. If I go on with 5 strips, even smaller. 10 strips, 30 strips. And you can see when the time I reach until 30 strips, the error is 0.001. Is actually quite small. If happens that I go on with more strip, let's say 50 strip, you can as if like now you can see from the error is equals to 0, where you can see the value from trapezoidal rules and the actual value of the integrations at this moment here looks alike. Of course, they may not be exactly equal to each other, but if I round off until certain decimal places, this will happens to be what it appears to see. The error is so small until it appears to display as 0 here. And this is the idea what is going on when the time we use trapezoidal rules to approximate a definite integral. And these applications here is applied especially when the time we have some case that the integrations is very tedious to do. For examples, one of the example is, let's say, ln x, integrate ln x, where in that case, when the time we want to calculate the definite integral, we need to make use of integration by parts, where the calculation is quite long. Although it still can be done, but the calculation is tedious and complicated. And of course, there is more functions that happens that it almost seems to be either very difficult, very tedious, or almost impossible for us to do integrations. Then we will make use of these trapezoidal rules to go for the calculations. And I hope this gives you a clear idea what is going on in trapezoidal rules. Thank you.